Hi everyone, I want to spend some time today and talk a little bit about the various materials that can be cut safely on a laser cutter or etched safely on a laser cutter. I provided a handout that has several items that are listed for both cutting and etching, and then also materials that are kind of forbidden from being used in the laser cutter. And you have to be very cautious and careful with certain materials depending on their flammability, right? And then there are some materials, as I mentioned earlier, that are completely forbidden to be used in the vinyl or in the laser cutter, just simply because they can create poisonous gases. They can create situations where the gases given off can deteriorate or corrode the interior of the laser cutter and things of that nature. So we do need to be very cautious and adhere to that list fairly strictly. That said, I am always one that's interested in experimentation as long as we're doing it safely. So, just consider that if you do have access to a laser cutter in the future. Most maker spaces in larger kind of metropolitan areas will have laser cutters available for you to use if you were to be a member of Makerspace or something of that nature. I mentioned on our handout the laser cutter probably is the most versatile rapid prototyping machine that we have in our labs at school and that I have in my own studio. I often think that 3D printing gets a ton of press as being this cool new technology that is going to revolutionize the world. It is indeed revolutionizing the world. It is not a new technology. It's been around for a very, very long time. It's just more accessible, and I think that's the key. Now, the reason I think a laser cutter is one of the most versatile tools is because the options for materials. Although 3D printing, we're now getting more and more materials that can be printed with and printed in. The laser cutter still has the ability to run the widest variety of materials with different physical characteristics. And so that to me makes it just a really important tool to be able to access for being able to ideate an idea or design. And this is something you should be thinking about when it comes to your other coursework as you continue on in our department. If you can harness the design skills that you're learning with Rhino and couple that with the laser cutter, there is no reason that you shouldn't be able to create some amazing things, amazing objects that, or at least allow you to develop those ideas, even if you wind up using a different material, even if you're just using it as a prototyping tool rather than a production tool. So I'm going to go over some of those materials and show you examples of some of these materials. I apologize that we're doing this via video, and so it's difficult to kind of, I'd love to be able to pass these around to you, and so it's difficult to get the kind of physical effect. Now, the first thing I want to show you is paper. Now, this is kind of a rough piece, but this is actually a thin piece of paper that has a photograph laser etched into it, and this is kind of unbelievable. This is a piece that one of my former graduate students, Joe Grenier, had made, and Joe etched this photograph. And I can even show you close up. There's areas where you can pretty much see through, almost poke through the paper, where it's really thin. I don't know if you can see my finger kind of back in behind there, but it's just amazing that once you get that laser cutter dialed in, that you can take something as thin as a piece of paper and really just barely burn into it in some locations, but others, play with that depth almost, right? And you don't think about paper having a depth or relief, right? This almost becomes a relief when you look at it up close. So paper is probably one of the fastest materials that you can cut. In that case, that was a rastered image that was created. Let me pull out some other materials here. I want to kind of keep in the same family of materials. These are some pieces. These were prints that were made, and then they had an overlay sheet that was laser cut. These were made by another one of my graduate students at the University of Wisconsin-Milwaukee, Jay Fox. Jay now teaches at Florida State, and so Jay had made a series of prints where he wanted to then have his cover sheet that was sewn on as an overlay, and so he has these cutouts, right, in the paper, and just beautifully, no burn marks, no, it's just gorgeously cut. So rather than, hand cutting, he's able to cut those overlay sheets to perfectly match the print beneath, right? So beautiful, beautiful set of pieces there. Again, using that in the production of the work, using a laser cutter in the production of the work. Another material, and I'll just hold up some of these materials. So other materials that are completely safe are materials such as this, right? Illustration board or mat board. We can pierce through that easily. No burning that will occur. Might get a little bit on the edge, but again, if you get your settings right between your power, that ratio between power and speed, you can pierce through this. You can etch into it. Very versatile material, quick to work with, cheap, right, or affordable. A lot of times, this is kind of fun. We would take, let's see if I can pull these apart. So, if we need labels for artwork in a gallery, this is chipboard. So that's just like a thick. It's almost like what cracker box or cereal box, right, would be made out of. And we spray paint the material, right? So we just put a coat of red spray paint over it, and then you come in and you laser etch the text right into the chipboard, and you wind up getting that color differentiation, right, between the red, and it really pops. So something so simple, right? We can make labels, no problem, right? So there's Lionel, Cameron, two of my former students, and Billy, third one, Rebecca, right? So these were for an exhibition that we put together, and so we made those cards. Again, chipboard, really versatile material that we can work with. All right, let me dig through my pile of stuff here. All right, other things that we can do are leather, right? This is leather. This was a gauntlet that one of my colleagues, prototype gauntlet, one of my colleagues named Adrienne Blair, who's a graphic designer, she made this for a little girl named Shay that were working with to make prosthetic hands. And we were making some leather gauntlets. This went on the arm. So she made this customized leather gauntlet. And it's both cut out on the laser, so it's a vector cut with a raster engrave, and then this is a 3D printed part that's bolted to it. So leather is an amazing material. My wallet, actually, one of my friends, former students, Eric Larson, made my wallet for me. So I don't have it on me right now, but basically it's fully laser engraved on the inside of the wallet with a pattern, kind of ornamental pattern. So pretty amazing what you can do with leather. As we're speaking about leather, here's this is a leather work apron that I use in my shop. And my leather apron I've engraved with the AppState Metals logo that I created. And also, got my name on the apron too, at the bottom of it, the base of it. So again, leather, just a beautiful material to work with in the laser cutter, and it does a great job. The laser cutter does a great job cutting it and engraving it. So I forgot to mention that wallet I have, all the holes for hand stitching it, they were also cut on the laser cutter. So you can prep your files to where you've got all your assembly holes for sewing that by hand already intact, and you're not having to punch with an awl or anything like that. Great tool for that. Some other places I want to show. This is also chipboard. So this has a hatch in Rhino. You notice there's a couple familiar hatch patterns, and so this is a case where we can choose different settings for the power and speed. So for example, these areas have been run a little bit darker, a little hotter than the areas above. Plus you've got a line that's closer to together, so it creates a density. But you're able to set various values for different depths, as I mentioned in our handout. So this becomes really versatile. Let's see. Cork. I don't have an example of this cut, but a thin cork material like this, that can be cut and etched. I know a lot of people making coasters that have cork inserts. Cuts beautifully. Linoleum that you might use for printmaking. It cuts very nicely, or engraves very nicely. It's too thick and dense to cut all the way through because of that kind of burlap backing. Some of you might use these pre-made print blocks that have linoleum adhered to them. Again, this is all of this has been etched around. Granted, this was a mess. This was one of Jay Fox's. He accidentally forgot to reverse his text, right, so that when it prints, it'd be the proper way. But he made one right after this. Real easy to invert, right, and make it right. But this etches beautifully. You can see there's a raised kind of surface to that, so you can ink that and then print on that. Super cool process to be able to use that. This is Easy Cut. Some schools use this for relief carving for printmaking. And in this case, this student wanted to test this out in ceramics. So what they did is they etched this pattern into it. You can see it's got both vector cuts that don't go all the way through, that are engraved, and then rastering that gives it the relief for around here. And then he rolled a slab and then rolled this through the slab roller, and it actually embossed the clay. So you could be making clay panels that are embossed and then assembling those surfaced clay slabs to each other and do some really cool things. This is where I think the magic of digital fabrication is combining these new processes with old processes we already do and seeing what the result is, right? This is Corian. This is tabletop material that is used for countertops, and this is actually engraved. This was for a piece. Now this has not been engraved. This has been CNC machined, but these lines around here, I made a design in Rhino, and then I made it, it was three-dimensional, then I made it 2D, and then I etched those lines from the 2D drawing of the three-dimensional object into the Corian. Then I filled that with ink, and I haven't done it on this one, but in the final version I filled it with a gold ink and then rubbed that in so that then you've got gold lines in that black Corian. It looked just gorgeous. Let's see, what else? I've had students experiment with things. This is a CD. Now this is not good because this is a reflective surface. So that can reflect your laser up and actually damage your lens. So normally if I'm going to do something like this, I will come back and put a protective coating on this, like even transfer tape. So you can see I'm using transfer tape here. This is on metal. So I'll use transfer tape sometimes as a kind of a resist, right, for either etching in a chemical etch later on, but I can have it come in and cut, and I can peel out sections kind of like you would vinyl, and then you're left with exposed metal that can be chemically etched. I can use it same way, this transfer tape, on reflective surfaces that I'm worried about damaging the laser. Put the transfer tape on, it dulls it, and then you can etch through it. It burns the transfer tape, no problem, easy, works really, really well, okay? Let's see. We haven't talked about, wood. Plywood up to about 1/4 inch. I can cut through on my laser cutter, which is a 60 watt. And so I can, both cut and engrave through. You do have to watch some plywoods. The plywoods like you get at Lowe's are pretty junky. They got a lot of voids in them, and they also use a lot of adhesive, and it just doesn't want to cut that well all the way through. I like to use a wood that I get from Amazon from a company called Woodpeckers, and they actually make pre-boxed woods of various sizes. So I have it already pre-cut to the size of my bed, my laser cutter, and that way there's very little waste. And they'll box that up, and it's easy to ship. And it's a good quality birch plywood. I really like using birch plywood. This is copper clad circuit board material. One of my former graduate students, Bryan Cera, he used to use transfer tape on this, over this as a resist, use a laser cutter to cut through, peel up the areas, and then he could make custom circuit boards by chemically etching the copper board. So pretty cool process there as well. This is a sheet of plexiglass or acrylic. Now I spend, on our handout, I spend a considerable amount of space talking about the difference between plexiglass and acrylic, which are the same, right? Plexiglass is the kind of like brand name of acrylic, and then the difference between those two, or that one, and then Lexan and polycarbonate. Lexan and polycarbonate are kind of, I know people cut it, but it's just nasty. You do not want to cut on a laser cutter. It creates a kind of black sooty line and kind of yellows, and then gases, off gases. It's just nasty. You know, it won't cut cleanly. But acrylic and plexiglass, you will get the most beautiful polished edge, and you can cut very complex objects. And you know, I might mention, you can get all sorts of colored acrylics, right? So there's a company called Inventables. They sell a lot of different varieties of colors. I know Hobby Lobby, but you can get really cool colors that they can be laser cut and etched. You get a beautiful polish edge. I made a note on our handout that if you are going to glue with the acrylic cement, that edge, if you're gluing edge to edge, it doesn't want to adhere, even though that adhesive is amazing, but because of that singed but polished edge, it doesn't penetrate the same way, and so it doesn't do a very good job. Now here's an example of a student project. This was John McGeen, one of my former students, undergraduate students, made this device. It's made of several layers of acrylic stacked up, and some of you might not realize, and I don't have this was for my old phone, but basically I can drop my phone down inside of here, right in there, and this is like a little speaker, so it actually amplifies the sound. You know, no power to this, it's just drop it in, and this shape of this conical region, you know, amplifies the sound out in the room. And you know, we used to use this in the kitchen a lot when we're cooking, have music on or something, and worked great, you know, until we got different phones, right? So now I need a new one, John, right? Make me a new one. Just kidding, but seriously, cool material, and this is solid, right? It's solid acrylic once it's all bolted together. So pretty cool project where laser cut acrylic was used. Let's go back here. So these are wood veneers. So this is a very thin wood veneer, and I always love going to woodworking stores and just seeing various materials, right? So this was etched into the veneer, and so makes a beautiful piece. This would be gorgeous on a lamp, right? As a lampshade. I don't know if you can see this, but you can see light through that. You can kind of see it right there when the light's shining through. So, you know, man, how great would that be if there was like a bulb inside and you were shining light through this thin veneer that had been etched. And plus, this is bendable, right? Depending on the shape or the grain structure of the veneer, you can bend this. So it's a flexible wood, right? Essentially, because it's so thin. So you might check out wood veneers as a material. All right, while we're on the topic of wood, let's talk a little bit about these samples. So, pull these out. So here are examples where the laser cutter has been set to engrave super deep by slowing down the speed, cranking up the power, or rerunning the same file in the same region over and over and over, and it just keeps burning deeper and deeper. And this is in thick wood. Now, so obviously, like we can't cut through something like that thick. That's too thick for my laser cutter. But you can start to engrave and engrave layer after layer after layer after layer, you know, down. And so here are some hatches that were done that way, playing with depth, right? So this is something I think most people don't take full advantage of. You know, they don't think about the fact that they're either thinking, well, I'm either etching or I'm cutting, but you don't think about the ability to have relief through that etch. So that's something I would like for you to think about, especially as it comes time for us to be able to create our reliquary box. That is a tool that often I think, because you're building surface, right? And any piece that, to me, that is really interesting has a lot of varied surfaces that work together to give it visual interest. And so think about how you can use that as a tool to be able to develop your designs. Now, this is an example of taking an image, and this is maybe a little hard to see. I'll zoom in on it, but basically this is taking a photograph. Now that's something you can do with this laser cutter. You can take a photograph, a JPEG, not a vector, right? Not a Rhino file, not an AI file, but a JPEG, and we rasterize it using a dithering technique, and it basically converts it to kind of like a dot, a Ben-Day dot or dot matrix kind of pattern, right? And so this could be inked and printed, just like comic books, right? It's a comic book kind of technique. So we could do the same thing with this, and we can control how tight, how dense those dots are, right? You can see this one over here. We inverted, I think, and did like a negative on both of these, but we made one a little denser than the other. Now I'll show you the flip side of that. See, we have a bigger version of that. So depending on the size of those dots to the size of the overall image, you can play with it. There's a program that's free online. It's called the Rasterbator. Strange name, right? But basically it's for making posters, but you can take any image and it will convert it to a dot pattern or various types of patterns that are dithered or rastered image. Pretty cool process. I didn't show this earlier. This is laser etched acrylic. So this is black acrylic that has been laser etched into, and you get this kind of white line. It's beautiful stuff. Just always impressed. This one's kind of scratched up from being in a box, but pretty cool thing there. A lot of times I'll use paint as a coating on metal for etching, for chemically etching. So here's our sculpture logo that Travis made, and I just etched it on a piece of copper. So spray painted it first, let it dry, and then come back and we burn through the spray paint. Even though we can't cut metal because this is a low power laser cutter, we're able to cut through the resist technically, and then we can stick this into an acid and it will attack the areas where the copper is raw, and we wind up with a etched piece of metal with relief. Let's see, what else? We talked a little bit on your samples for your business card about etching on anodized aluminum. This is some work I did for a local company, Suga, where I was experimenting with their logo on sample pieces. I don't know if you can see that, if it's focusing or not, but that works really well. A group I used to work with making prosthetic hands called Enable. This is their logo. So these were pre-bought anodized aluminum keychains, right? And then I just repeated the logo over and over, kind of similar to what I'm doing on the business card. And you get something that looks like that. So again, you might look out there for various things you can buy that are pre-anodized that you could throw in a laser cutter and put a cool design on, turn around and sell it, right? Make a little money. And that would be a cool thing, right? All right. Now, let's talk about a few specialty things. Now, later on in the week, we're going to be making a reliquary box. And that reliquary box, I'm going to show you how to use a box making tool software that already figures out like dimensions. If you know a certain size of the box, it'll help you lay out flat things that can be then cut on the laser cutter. And then when it comes off the laser cutter, it's easily assembled by using finger joints or things like that. Now, this next thing, this is called a living hinge. Now, this is basically slits that are offset. I don't know if you can see that, and they're cut all the way through. Now, I'm going to pull on this wood. I want you to watch this. I'll show you close up. So you can see how that expands. So you can almost see through like a screen. This would be another cool device to use for a lampshade later on. But the neat thing about this is that you can take now and bend that wood, and this is about it's a little thicker than 1/8 inch. It's probably about 3/16 inch thick wood, birch plywood, and look, it's springy. See that? And so this is called a living hinge. They've been very popular with the laser cutter crowd, people that have laser cutters. But this software I'm going to show you actually has the process to build this kind of flexible lid into it. So you could design an entire box with a flexible lid that you know, opens up. Right? This was for a iPhone case that I'd made years ago, and I've got an iPad case that I designed and have my iPad in with a wood case that's bent, and then you can polyurethane this and it'll still move, and you can do this process in very thick wood. I think the handout that I showed you on different processes has a whole section on like just images of objects that have living hinges. So check those out if you're interested in this process. Most students see that and they're like, oh my goodness, like how cool is that? It's kind of overdone now, but man, when it came out, it was pretty cool. All right, a few other things, specialty things. Now, this is a process. These were samples I made of a process where I take acrylics. This is plexiglass, and I laser etch into the acrylic to create relief. And then I come back and I sprinkle powder coat. And powder coat is a very durable paint in powder form that is usually fused onto like patio furniture and light fixtures. Anything that's going to be outdoors a lot of times, even sculptures, will be powder coat. It's an electrostatically charged powder that's statically charged and adhered to metal objects typically. And then the metal object is put in a giant kiln or oven, and it fuses the plastic powder. So usually it's a plastic paint powder material. And I figured out pretty early on that you could do this process. So this is a candy color of candy blue that is put on a piece of acrylic, then it's opaque white. Now what it winds up doing is you can see through the blue, you can't see through the white. These were samples made by one of my former digital fabrication students, Lionel, and Lionel did these tests for me, and then we wrote an article for Hackaday that got published. And so you can start to layer these powder coats and fuse them to acrylic to create custom designs that are colored in clear acrylic. And so, man, pretty cool process. And we use powder coat all the time. We do that in my metals classes. We usually show students how to do that. So that's a cool application for the laser cutter. You have to be careful. Basically what's happening is you're putting the powder down over that etch form, running the laser again over the same design. It fuses the powder, but it only fuses it where the design was, and then you lift that out, and then you can blow off the loose powder that's in the areas that didn't have an etch design, and it's clear again, and then you just wash it off. But you don't want to get that all over in your laser cutter. You'd want to ask or have your own laser cutter before you start messing around with that. All right, last thing, marking. I talked a little bit on the handout about this difference between etching and cutting, and then there's a section that talks about marking, and I discussed the fact that we can't cut metals with a standard CO2 laser cutter. You can with a fiber laser, and those prices on those are getting much, much cheaper. I think in the future probably we'll have a fiber laser in our department that we can pierce through metals, stainless steel, really hard metals like how cool is that going to be, right? But for the time being, if we have a low-powered, CO2-powered laser, we can start working with stainless steel and we can mark it. Now this is a little bit different, right? In the anodizing, we're marking it, but we're burning through the anodized layer. Stainless is far too hard to etch. So instead what we're doing here, and this was a sample made by Bryan Cera, mentioned earlier, good friend of mine, and Bryan figured out that he could take alcohol and plaster of Paris, mix it up, coat as a paste onto the stainless steel, and then stick that in the laser cutter. And the laser cutter, when it would burn at its highest power setting, would actually start to create an oxide layer on the surface of the stainless steel and give you a black mark. Now you can see these white areas are where it was kind of the plaster of Paris was chunky and thick. But if you get an even coat, you could get some pretty amazing results. So we play with airbrushing that on, so you got a nice thin layer, and then you can etch that. Now, since writing that article being published on Hackaday on that process, I've found that you can use molybdenum spray. It has similar characteristics, and so you can. It's a spray you can get at like a parts store place, like auto parts store. And then you can spray that on, and then etch over that, and it will actually leave a black mark. And this is where this came from was there's a material called Cermark. It's CERMARK. It's very expensive for a spray bottle of it or spray can of it, or kind of pricey. But you can spray that on, and so that's how this was made. This was a stainless steel flask right from Amazon. This was made by Larson, one of my former students, and he took this old Volkswagen. Drawing of the logo with the specs on it, and he basically marked the stainless steel. And these were gifts he gave out to different people. So again, how cool that you could just go buy like a stainless steel drinking flask or even an anodized aluminum drinking flask, right? And you could start to lay a pattern on that and etch that and sell that as like a specialty kind of like gift to someone. Again, I think in terms of versatility, the laser cutter, it walks all over a 3D printer. It's just the fact that most people don't know all of the things that you can do with a laser cutter. And so I encourage you to dive into researching a little bit and thinking about ways in which you might be able to use a laser cutter. Our opportunities are going to be basically this week and next week. We're going to be able to create with the laser cutter this week. We'll be doing the business card in anodized aluminum, etch only, right? But using the vector as an etch. And then toward the middle of this week, I'll introduce the reliquary box project. I'll talk about what parameters are going to be for that. That will be an opportunity for you to both cut and etch. And I'm going to provide the wood. We're going to be using about a 1/4 inch thick birch ply for that. I'll provide all that. So you're going to learn how to make the files that you can then impose your rhino patterns that you want to create for that box. And then we'll cut it out, and then I'll ship you those parts. You'll be able to assemble that box with a lid and everything. And so that'll be an opportunity to use a laser cutter there. And then next week, we're going to design the lampshade. I'm going to teach you a new program that will help you create form, 3-dimensional form that is far beyond just a standard kind of square or rectangular box kind of shape. Like I said, this week and next week we'll focus on a laser cutter, and then we'll get into 3D printing after that. But I want to spend a considerable amount of time these 2 weeks on laser cutting, just because I think it's very important as you're learning how to 3D model. There's such potential, for the 2D designs that you're doing now for the laser cutter, but later on we're going to be able to take 3D, let's go back up on that. We can take our 2D designs and make 3-dimensional things like I was talking about with relief, but then we can flip that on its head and say, let's design something 3-dimensional, but then re-output it as a 2-dimensional thing that gets cut and then gets assembled into a 3-dimensional thing. So I don't know if you realize what I'm doing here, but I'm basically working 2D to 3D, 3D to 2D, and back and forth. And that to me is so cool. I mean, how awesome is that we can use this tool to just make such a variety of things. So again, I encourage you, I'll be talking about services, so I encourage you to look into services in the future, or maker spaces in your local community where you can access a laser cutter. Man, make sure you're getting this information. Make sure you're reading those handouts I give you, because I just feel like if you come out of this class with this knowledge of harnessing this technology, there's like nothing that you can't do in making mock-ups and you know, mock-ups for clients or future jobs. You know, amazing stuff. One last thing, you should check out. There's a student of mine. She lives in Houston. Rebecca Hewitt is her name, and she worked for me as a technician in the lab that I created in Milwaukee. And Rebecca, when she moved to Houston, she got a residency there. She did that, I think, for a few months. I can't remember how many months that was. And then she and a friend started a business. Excuse me. And it's called Laser Cut Co. Okay, Laser Cut Co. Check them out on Instagram. They bought a couple laser cutters, and they just do that as their business. They do it amazing. They've got all these different options for like things they can cut and ways they can cut things out, and they're doing stuff for like weddings, and they're doing stuff for parties and interior designers, and I mean, and they do everything from the physical cutting, right, but also design work too. So man, shout out to Rebecca. Super smart person, always was smart, always was like thinking, how can I use this? And so now's the time. Like, she did this, she's had this business for a couple years now, I think, but excuse me. But check her out. Great example of a student taking what they learned in school and just like scaling it up, right? So check her out for certain. And yeah, and just like I said, spend some time. Think about this. You can cut such a large variety of things with this cutter. So take advantage of it while you're here in school. All right. Sorry for the long video. I want you to be able to get the content we would get in a regular class if we were meeting person, you know, face to face. And I hope this was helpful for you learning a little bit about how the laser cutter works, seeing it in action, and learning about materials. All right, so thanks for checking this out, and can't wait to see the designs. All right, see ya. Bye.